Good evening, everybody. So today we have a meeting about the Kaggle competition or the organized by the H2o company. So it was devoted to the prediction of the answers by large language models. And one of the organizers is Dmitry Larko, who is our first speaker. And he is Kaggle Grandmaster, and it's our great pleasure to have him here. And also other participants, Samvel, Aleksey, and others, they made a good contribution to this competition, and so it's a great pleasure for us to have you here. So Dmitry, please start.
Oh, thank you. So that was a very interesting opportunity for me. That was the very first time I was seeing the competition from the other side, right? So I never organized a competition before, and that was a really interesting experience. Yeah, so the first thing first, I'll start with introduction, when I'll just give you a couple of words about organizing competition, and I mention H2o Studio at the very end of my talk. So yeah, all right. So my name is Dmitry Larko. I just realized I'm doing Kaggle for 11 years. So Kaggle is not lying. I mean, actually, I joined the Kaggle platform 11 years ago, which is actually a scary number, I must say. So yeah, I participated in various competitions. I never was really vocal in any other type of contributions. But yeah. Fun fact, actually, my dad is also Kaggle Grandmaster, and actually he was the person who introduced me to Kaggle. So he actually was Kaggling like 1 year more than I did, and I do. So let's talk about the hackathon. And yeah, I think about the hackathon like, from a timeline perspective. Before 4 weeks of the hackathon start, we actually got our final dates for the conference because H2o planned to have a conference in San Francisco, and we decided to organize a hackathon, dedicated to this conference as well. And 4 weeks before competition start, we actually get a final date. It's going to be November 7th. And that gives us again, 4 weeks to organize a competition. And requirements was quite, we set ourselves a really interesting requirements for this competition. It should be fun, engaging, really approachable. So that means it's going to be not a big data set, not very demanding from a hardware perspective, ideally. And it should be short, something you can run in 1 week or 2 weeks at the most. And of course, we would like to use a Kaggle platform to do that because it actually will ease our requirements on the resource. So we don't have to, create a platform ourselves. We just can use the existing stuff, And of course, Kaggle platform and community is extremely engaging, right? Like people are actually very active. So it's easier to organize something on Kaggle just because you will have more participants that way. Right? We spend the 1 week brainstorming different ideas. And I must say, we still have a couple of ideas in a backlog. So we might organize something, along this, using these ideas later down the road. Who knows? We'll keep you posted. But in the 3 weeks before the competition start, we actually got our idea, which we decided will fit the Kaggle platform ideally, right? So why don't we just ask a few LLMs, let's say in our case, it was actually 7, some questions and record the answers and ask participants to predict which LLM actually generates the response. All right, a very, very interesting idea. So we had 2 venues how we can actually get the data set. We can search internet and find the questions, or we can actually ask ChatGPT and Claude to generate the questions for us. And that's exactly what I did. Majority of the questions, around 75%, were generated by ChatGPT and Claude. Like one of the examples you can see on the screen. It was very straightforward, actually, thing to do. So I spent like a couple of days generating questions and searching some interesting examples over the internet. And then as soon as I have a data set, I decided, okay, now I need to run through the LLMs. And I realized at the moment, we didn't have any machine available to do that. So all the GPU machines we had usually I have in my possession weren't available. So ordering a new machine, like, on some like AWS or any other platforms actually can take some time because there was not a lot of available resource at that moment. So my solution was I switched to Llama CPP. And Llama CPP is a nice GitHub project. It actually allows you to inference the LLMs on a everyday hardware. You can, technically speaking, literally you can use a MacBook to chat with LLM. Of course, it might be quite time consuming. You will be somewhat limited to the smaller LLMs, but it's still doable. In my case, I use like a beefier machine to do that. So I was able to even incorporate some 70 billion models, which again took me a while, but it actually was worth it. Most of the models, actually all the models I use was actually, I took from the blog. That's a very active Hugging Face contributor. He has tons of quantized models in his Hugging Face model repository, including some GGUF format I need for Llama CPP. So I basically use his quantized models for all the 7 models I use in this computation. So the data set itself, now, as I mentioned, it was 7 models. I had 948 questions in total across 10 different topics. The topics was never revealed to the competitions, to the participants of the competition, because I was afraid it might be too leaky actually, and that could possibly make a competition less fun. I think one of the biggest fear I had during the creating of this competition was, I was so afraid I will introduce, like some sort of a leakage, or the problem going to be not that engaging and it's not that challenging actually. It's going to be cracked in a day or so. Luckily, it wasn't the case. And again, I end up removing 200 plus questions because LLMs, 2 or more LLMs actually generate very similar answers. An example one you can think of, I had a set of questions asking factual information, like what's the capital of France, for example. And for this, like a very simple question, most of LLMs, they respond like, like a Paris, or capital of France is Paris. So the answers was, so similar and so short, was kind of boring, and I removed these questions out of the data set. I also would like it to keep this competition, again, very responsible in terms of the metrics. So I actually did a split based on the questions. So let's say that means all the responses for the same questions goes to the train or test dataset only. There is no like split the questions across the private and public portion or train and test portion. That also somewhat protect me from the leakage, because as you know, most of the, actually all the responses have exactly 7, all the questions have exactly 7 responses. So that if I split them in any other way, actually, you can use this information because it's introduced somewhat leakage. It introduces some sort of a leakage, and I don't want to do that. Yeah, I also, in some rare cases, LLMs I asked, they failed to produce response. That's why we have NAs in the data, and I just forgot to clean it. And there was a couple of questions on the forum, on the discussion forum on the competition, how to deal with NAs. I was like, oh my God, I forgot to clean them. That's completely my fault. Sorry for that, but next time I will definitely check for NAs. So several fun facts about the model and the data set. Llama 70B turns out to be the most talkative. It's not just response to the question, it's also asking you, some question in return. And because I try to keep the prompt I use the same across all the models, that gives me some difficulties. Yeah. These LLM models also, they think actually they've been trained by OpenAI. And that's all the time. But I'm assure you there's no OpenAI models in the data set. It's all very open source. And my favorite question is, I found it on the internet. It's like, is it morally right to kill mosquitoes? And actually, to my surprise, there was a very thoughtful response by LLMs to that, like a kind of silly question, you know, if you may. And one more thing, actually, kudos to the second place team who actually use a clever post-processing, exploiting the fact there was always 7 responses per question. Yeah, I thought about that. I really, again, my worries was that it might be actually introduced some leakage. Luckily enough, it wasn't enough information anyway, so the competition, you know, kept to be engaging. But yep, still kudos to them. That was a nice hack. A few words about the baseline, just to give you some sort of the perspective, how it's been actually, because I think a lot of people found it's interesting to beat the Philipp baseline, and a couple of points on the background of this baseline, how it's been created actually. On October 24th, Rob actually created the competition itself and asked our Kaggle Grandmaster group inside the H2o to check, you know, like, hey guys, you can download the dataset, play around it, let us know if everything works for you. And 3 hours from that point, Philipp actually submitted his baseline. So it basically took him 3 hours to make it. Interestingly enough, it didn't took longer for participants to kind of match and beat the benchmarks, both on a public and a private score perspective. So basically, it's actually took being to 7.5 hours to beat us on a private leaderboard, which wasn't, of course, revealed, but I knew that from the beginning. And it took 19 hours in total to beat this benchmark publicly. So I would say this is a very fast, you know, given that Philipp actually usually creates a really strong baselines. But the reason why actually this benchmark was generated so fast and beat it so fast, because both participants, both Philipp and Bingo, they actually use H2o Studio to produce their solutions, which I found quite interesting. I think the major difference between Philipp and Bingo submissions in that case, Bingo used a Mistral 7 billion, and because it was one of the models used in the response generation, I think it gives him some advantage, while Philipp used a different model. I don't recall which one. And again, so what's H2o Studio? A couple of words about it. I'm not going to spend any more time discussing it. Oh, sorry. So H2o Studio basically is our no-code solution you can use to train and fine-tune LLMs. Again, it's more importantly, the most important piece, it's a no-code. You don't have to code anything. You can just spin it up, you know, select the LLMs you would like to fine-tune and train, and give it a go. And in the recent releases, they added a classification head, so that's why it's so convenient and straightforward to use this in this particular competition, because you're not just able to generate, you know, and fine-tune LLMs in a generative cases, but you also can use them to classification, which proved to be extremely useful, at least for this particular competition, which might be, you know, and I mean, maybe it's actually indicate the end of the BERT-like model era for Kaggle competition, because LLMs actually produce better performance compared to them. Well, basically, that's all the slides I have for you, and I'm open to the questions. Thank you.
So according to our schedule, I think the questions will be at the end. So now I think it's Samvel and Aleksey. Yes. Sorry. Just a moment. Samvel, just a moment. Please unmute Samvel and Aleksey. Please unmute yourself.
Yeah.
Okay.
Yep, I do it.
Okay, please start sharing. Okay, we see the presentation. Okay, now it's full mode.
Okay, just give me a sec. So thank you so much, Alexander, for the opportunity to be here today. And I also would like to thank you, Dmitry, for that you find the possibility to come to us. It's always very interesting to see how the competition were organized, and it's like a side to the backstage. For me, it's the most interesting part, maybe in the competition. So our report today we will not fall too much into details, given the chance our next speaker to describe best solutions, the best winning solution in this competition. But anyway, it is from the perspective of the Kaggle beginners, and maybe it will be interesting for newcomers, you know. The title of our slides is To Catch Up Log Loss 1 and Philipp Singer's Baseline. Two words about ourselves. Let me introduce us. We are the teams of two aspiring data scientists, bridging the gap between two countries, between Moscow and Budapest. We have something common with Aleksey. We both are Kaggle freaks. We are both trying to fit to find our first job in data science, and maybe you can see that we have same hairstyles. I will not stop too much at this slide because Dmitry already told us a lot. I just want to mention that our metric was a log loss. And due to nature of this hackathon, we have 92 teams. It's not too much for the Kaggle, but for the hackathon, it's very good. We had only 14 days, and we started to compete at day number 12. 50% of the data, public leaderboard, we were represented by 50% of the data. And I just want to share with you 3 reasons for our team to be in this competition. Firstly, it's as you know, it's organized by H2o team, and H2o is known for the attraction top minds from the Kaggle community. And the involvement for us, it's like a high quality competition. The second reason is the topic of NLP and language learned models, which gained significant attention recently. And lastly, it's that on the public leaderboard we had benchmark created by Philipp Singer, who is the #1 in the Kaggle global ranking. 2 words about our team strategy at this hackathon. Due to the short nature of the competition, we've decided to split in 2 parallel tracks. My track was like a try more and fail fast. It's like a random search style. I've tried different strategies and trying to realized what will work and what will not work in this competition. And what, Aleksey, you are doing at your track?
And our choice was grounded in starting with a basic of NLP and progressively complicating our methods and models. The ultimate goal was systematically reduce our log loss, but this task easier said than done. You can continue.
And in the last days of the competition, we've decided to mix and boil our findings and just to realize what will be okay for the leaderboard. Our next 3 slides, we split it in 3 different approaches. Each approach had up to 10 and maybe 20 models, and we just try everything, you know. Our first approach was very basic. We just decided not to fall deep into the meanings of the answers of the LLM. And my assumption was that we can figure out with very basic predictors, like count sentences, the length of the responses, the ratios, and etc., etc., etc. So we've generated about 130 features, and on my side, I just fed it into 3 AutoML frameworks. It was Octogloon, H2o, and PyCarrot. And for some models, we made tricky manipulations with feature permutations, feature importance, etc., etc. Aleksey?
As I said earlier, I focused on by counting the number of words, number of punctuation, the length of our text, and count stop words. And then I ran in this numeric data into the model and got our first score equal 1.30, and it was at least something interesting.
On our second approach, we've decided to play with BERT-like models, embeddings, and hidden states, which we can take from the BERT-like models. We created different sets of the predictors. We played a bit with clustering, fed everything into the boostings, and realized that our score is just lie between 1.3 and 1.7. And that was not enough for us. And for us, our first aim was just to get to the log loss 1. I know it's not good for this competition, but for us it was a like a huge big target which we had to achieve. Aleksey?
And by complicated the techniques and generating new features from helps TF-DF factorization, I create more 250 new features, and after it from our text, and then I paste in these columns new features, the ensembles models, and we improved our result on our position on the leaderboards, but of course it was not yet the one of the Philipp Singer. And we go to next our approach.
On the last stage of this competition, we had not too much time. As I said before, we continued to be splitted, and I've decided to try H2o LLM Studio. What a surprise! Yeah, and it works perfectly for us. Unfortunately, I have only possibility to play with LLM Studio at H2o Aquarium, and that allows us to launch 2-hour session, and that was enough only for training Mistral model for just one epoch. And Aleksey?
And I implemented the solution on transformers from the last NLP competition, and we again improve our last score, but we have not yet reached the philosopher's stone in this competition.
Yeah. So as you see here, the slide, it's our chat. finally we got very, very close to Philipp Singer baseline, and for us it was a huge achievement, you know. And at this moment, Casino, I said that sometimes Kaggle for us it's like a Casino. Casino started to work for us, and I decided to go further and to rent the standalone server and install the H2o LLM Studio, and I spent about 5 hours trying to install GPU on Ubuntu, and for me it's absolutely new area. I failed. And we had just 1 hour before the end of the competition, and Aleksey said, "Okay, let's do something else," and we just make a very, very funny little data magic, and we just averaged our best attempts and landed to the place number 8. What for us, it's a really, really, really good result. As an outcome, I've written 2 articles, one in Russian, one in English, and published it at Harbor and Medium. Here are the links. You can maybe later read about it. And Aleksey, what is your outcome for this competition?
I won't say that if you can spend your time and your efforts and step by step, you can improve your solution, and if you understand and deep to this problem, and finally your result was the great, I think.
Yeah.
You have to deep step by step in any competition, and I think you can get necessary for your results.
Yeah, thank you, Aleksey. Now just one more minute. Next slides will be from Rashmi Banthia, who is on place number 3. She was with Luca Massaron in the team with Luca Massaron, and their solution is very, very interesting. Unfortunately, Rashmi from the second place can't join us today, but he said please say hello to everyone. And just bonus slide for future LLM and NLP learners. I just want to share some links which could be useful for next for the learners. So that's all, folks. Everything. That's all what we wanted to say you. Please send your complaints, suggestions, and maybe some job offers or team invitation to our emails, and please come to our LinkedIn profiles. Thank you.
Thank you too.
Thank you very much. So Rashmi, please, can you share your screen?
Sure.
Yeah, we see it, but yeah, full mode.
Okay, ready?
Yeah, great.
Okay.
Thank you.
Thank you. So my name is Rashmi, and I'll be talking about my solution for the Predict the LLM competition. This was, I worked with Luca Massaron, and we ranked 3rd on this competition. It was hosted by Rob, Dmitry, and team from H2o.ai on Kaggle. We had a lot of fun working on this short assignment. Thank you guys for hosting this. So this was a multi-class classification problem. It had 7 different classes. We were not given the LLMs until the competition ended, so we were only provided the numbers 0 to 6 for the target. The metric was multi-class log loss. We were given about 4,000 samples for the training with the target and about 1,000 samples for the test with no target. So the training set had 568 questions, and each question was repeated 7 times for different LLM. So you can see the same question being repeated and the target being 0 to 6 for every single question. And the same thing for test. So this is our solution overview, and I'll be going into a little bit of detail into some of these. So basically, we work with Zephyr 7B beta model with different hyperparameters and few other LLMs. We did the pseudo labeling as well because we had the test set, full test set, ensembled them with the Nelder-Mead. Luca came up with a lot of tabular features, which were also super helpful. So I'll be talking about the log probability features, and then we ensemble basically the whole thing. So just to motivate, the large language models are becoming very large indeed. The model that we fine-tuned was somewhere over here for 7 billion parameters. And of course, we have much, much larger models after that. And the BERT is somewhere here with 340 million parameters. So to fine-tune a large language model with 7 billion parameters, if it was a full precision model with float 32, we are going to need a disk space of 28 gigabytes, which would, if we were to fine-tune in full precision, this is going to take about 3 to 4 times the disk space. You're going to need that much GPU memory, 4 times the GPU memory of this one to be able to fine-tune, which we don't have. I mean, I only work with a single 4090 to fine-tune the model. So basically what we used was 4-bit quantization. The model was about 4 gigabytes in space. It took about 17 gigabytes or 18 gigabytes of GPU RAM with batch size 2 for the fine-tuning part. And we used the Zephyr 7B beta. Mostly all the ensemble was with this model, but there were a few others as well. We also used QLoRa with fine-tuning. So this is actually the quote exactly from the paper QLoRa. It's an efficient fine-tuning approach that reduces memory usage enough to fine-tune a 65 billion parameter model on a single 48 GB GPU while preserving the full 16-bit fine-tuning task performance. The actual code, I put the link, and it's only a few lines of code to add QLoRa to the model, and it works really well. I also referred to H2o LLM Studio because their code is public. I was able to actually see what's going on in the GitHub and do it on my own training code. So the training code I wrote was my own, and the inference, of course. But I did refer to the GitHub, so which was super helpful. So I'll talk a little bit about how the pseudo labeling works. This was a perfect example to do the pseudo labeling because we were given the test set. So we are given the training data. So this is the usual training process. So give the training data, train a LLM or any model for that matter. What we get out is a fine-tuned model. You have a predictions on the test set. You also have the out-of-fold predictions. Now, these out-of-fold predictions were utilized to do the ensemble. The predictions on the test set were utilized for pseudo labeling. So in this step 2, what we do is we take the training data as well as the predictions on the test set, and then we train the model again. So this model is better than the model that we had in step 1. So we have, again, the test set and the out-of-fold predictions. So it's important to keep the validation set same for step 1 as well as step 2. So we don't change the validation, we only add to the training data set. We basically ended up repeating this process 3 times because as the pseudo label improves, the final ensemble also improves. So we were able to do this pseudo labeling at least 3 times in the process, the whole process. So since we had multiple LLMs, we wanted some way to combine these rather than just simply average. So what we did was to use the Nelder-Mead method, which is the SciPy optimize function. It gives us the weight for each of the LLMs, how much to weigh them for ensemble. So we train multiple LLMs, then the ensemble, we get the test set predictions, and we pseudo label, and we repeat the process. So somewhere along the line, we also had Luca's tabular data features also in the whole submission added. So next, I'll talk about some of the tabular features, because these features were pretty important when we finally did the ensemble. So log probabilities being one of them. So what happens is the models that we are dealing with are all causal language model. The job of this model is to generate text, for example, GPT, Llama 2, Mistral, Zephyr, and many, many more. So many of them on Hugging Face. These models are trained to predict the next token in a sequence given the previous tokens. Oops. So you have model and you input the text or the tokens. What you get is the output logits, where it is batch size, sequence length, and the vocab size. Seems like there's a question. Are these trained LLMs of the ensemble different QLoRa adapters of the same base model? We had different, we had Zephyr 7 beta, Mistral, and one or two more. So yeah, different models. And each model took only about an hour to train with the 5-fold. So we did the 5-fold group K folds, and it only took 1 hour, the whole thing. I was done training one model within an hour. So once you input the tokens to the model gives you the output logits, which are of the shape, basically batch size, sequence length, and the vocab size. You do the softmax over it, and then you do the log over it, you get the log probabilities. So given a token, so basically what this means is, given a token sequence as input, model predicts the next token by outputting a probability distribution over the vocabulary. So for example, if the logits were of shape 1, 512, 32,000, here 32,000 is the vocab size. 512, this can be anything depending on the data set, and this is your batch size. So this can be 256, 600, 300, however you like. So once we have the log probabilities, we could do various features on these log probabilities: max, min, range, mean, lowest, entropy, perplexity, skewness, all of these. And we did the log probabilities from many, many different models. We have a whole list in the solutions posted. We did not try the 7dB models, but I believe what Dmitry described, if you were to use a 7dB model on a larger CPU, we probably should be able to extract the log probabilities from the model also. But we only limited ourselves to 7B and 13B. The code is also public for this part. I have a radio demo. I can post this link on the chat, and I can show you also. It's a great way to showcase what we worked on. I'll do this right after 1 or 2 more slides. I had 1 more slides that seems to be missing. Yeah, this is here, sorry. So there were other interesting solutions on the forums. One was, the first place had the mean pooling with the start and end. So they only mean pooled the particular response for only the response, and they provided the extra responses for the from other LLMs in the input. The second place had really good post-processing, and the fourth place had also good way to rearrange the data set. So instead of training it on 4,000 samples, they actually trained it on only 570 samples, which was pretty neat, and they had a good score with the DeBerta models. Let me show the demo for the Gradio, which is, and I can put this link on the chat if you want to try. Hopefully it won't break. I'll put this in the chat. So I have it open here. So you can, I only put the sample, like it's not the full data set. So you'll only see like 14 samples repeated over and over. So you can pick one sample here and you can submit this one. Let's see, hopefully it doesn't make a mistake, but there are times when see, it did make a mistake actually. So the actual value is 0 and it says 6, but we can try this one. This one is correct. So what was expected. I think that's all I have for the slides. I'm happy to take other questions if you have any.
Thank you very much, Rashmi, for your talk. Great presentation and great results. My congratulations. So just a moment, 1 second. Okay, so now I allowed you to unmute everybody. Sorry. There is echo. Rashmi. Maybe Rob Mulla, if he's still with us, do you want to make any comments, suggestions?
No, I just want to thank everyone who participated. I think when Dmitry and I were working on this and a few other of the H2o GMs, we weren't sure how much involvement there would be from people, and we were really blown away by such great solutions. So it's really fun to hear your perspectives as competitors and all the creative things that you all did. So I just want to say thanks for participating, and we really appreciate it.
Thank you very much, Rob, and great competition. Thank you very much for organizing it. So we have some questions in the chat. Let me maybe read them. Now, colleagues, don't hesitate. If you have a question, you can unmute yourself and ask. But let me start with the chat.
Just a second. I just want to one more time say thank you to Rob and Dmitry. Guys, please don't stop. Please organize next competition. So because when it's created from your perspective, it's much more interesting to participate in these competitions.
Yeah, I think it's great. And if you organize something, please let us know. Send me a link. I'll put it in our chat and make more advertising, maybe some other people, and maybe we can organize some kind of, informal discussions and during the competition, because it's maybe some introduction or whatever. Okay, so why did you choose these LLMs? This is a question to Dmitry. How do they correlate with each other? The sub-question.
Honestly, there was no science behind how I choose the LLMs. So, obviously, Llama 2 was all over the place, right? People was talking about it. So I definitely have to stick with this family of the models, and I decided to, try 3 of them. Oh, actually 4 of them, right? 4 of them my models actually from Llama 2 family. And because I have them, I also need to introduce some similar size model, but from a different perspective. Like that's why WizardLM actually came into the equation, because it was the only model I found the quantized weights for 70 billion model at the moment. And Mistral was just recently released, so I added it actually very last moment. I think it's been released like 2 days before I actually was able to score it. So it was, yeah. So it was actually, it kind of grew naturally, there is no science behind it, which might be actually not a very good idea how to approach this.
And the sub-question, how do they correlate with each other? Or have you analyzed this? Or
No, that's actually maybe that's something I can do, because now I have a submission, so I can actually analyze which models tend to be better predicted compared to the rest of them. So you guys actually gives us a lot of submissions to work, so we can actually do this such kind of analysis.
And another question to you from Rashmi. What was the process to remove the similar responses by the language models?
So it wasn't extremely complicated process. Let me share the code for a sec. Am I sharing the screen? Yes, I am.
Yeah. Yes,
yeah. All right. So basically, I used this particular model to do text to vec. So I vectorize all the responses. I measure the cosine similarity. In case if the maximum similarity between the pairs of the model was above 0.97, at least one actually. I just need one single example, right? Because I have 7 to 7 comparisons, right?
Yeah.
So I just need just one of them to overcome the threshold. In that case, the question is basically dropped, which brings me to 25% of the questions being dropped. So it was quite straightforward approach. I don't want to overcomplicate it, but it seems to be. And again, the goal was actually to remove actually similar questions. You know, like a Paris is the capital of France, or capital of France is Paris. You know, that's these questions been effectively removed, just because I don't think it's fair to the participants to introduce such questions to the data set.
Rashmi, do you want to add something or comment? We don't hear you. Probably you're speaking to the different account. Okay, so there is another question in the chat from Amar. I don't know, it may be for Dmitry or Rob or all of you. What do you think about OpenChat 3.5? Amar says that he tested it, and in his opinion, it is the best alternative to the product OpenAI.
I actually agree with Obaran in a sense that Llama 70 billion might be an overkill in a in a lot of cases. We actually see this like across various of our customers actually. So 70 billion to even 30 billion, 13 billions actually might be too big. 7 billions is enough in a lot of cases. And it can be Llama 2 and can be Mistral. I haven't worked with OpenChat 3.5 enough to say is it better or worse, but it could be a nice alternative. So, but again, it's not necessarily have to be a big model, that's for sure. In some cases, you just need to Rashmi point actually, right? You don't have to train a classifier on 70 billions. That might be, an overkill. You just 7 billion is really covers a lot of use cases.
Okay, thank you very much for the answer. Another question, Dmitry, to you. Why didn't you consider train test privat split topic-wise?
Topic-wise. Yeah, it will provide much less potential for leakage, but there is the competition is a function of the data set size, right? And the time. I have a very small data set, right? And the aim of competition was to be engaging for 1 or 2 weeks. So that's why I actually decided not to split it topic-wise. And I want to be fun. So that's why I decided not to split the private public set topic-wise, because I do not want participants to anticipate for the shakeup, it can be a nice exercise. It could be a nice experience, educational wise, but I really wanted to keep it simple. That's why we have a log loss as a metric. That's why it's a balanced actually, right? I just want you people, to get this feeling you have an improvement in your local CV, and you see the improvement on leaderboard, because it's very catchy, right? It becomes like a very catchy cycle. That's how you got hooked to the Kaggle competition, and that's what I mean by saying engaging. But if I had a bigger data set and a bigger timeline, absolutely 100% it would be topic-wise split actually, like for sure. At least between train and test.
Thank you very much. So there is a question in the chat. Rashmi, how do you combine the log probabilities from the models with different vocabulary and tokenizer?
Let me share the relevant code. It might be more clear. Can you hear me? Okay.
Yes, we hear you.
Yeah.
Okay.
It's fine.
So this notebook is public, so you can actually check it out. So what happens is when you actually call the model with input IDs, and this is the output you get, then the output, and then you do this softmax over it. So the shape for this one is, let me see, I have it open here. So what you get is token probabilities over the logits is basically the input sequence length, and the 32,000 is the vocab. But after that, what you actually do is you do the, you take the mean, and these are the features that are directly used. We are not using the full 32,000 features, but we are combining the features by mean or max or range and all of these things. So this is how the log probabilities part was working.
Thank you. Can I clarify a question?
Mm-hmm.
I just remember in original paper they combine statistics from different models, and maybe I misunderstood. I thought they combine on token level, but maybe they
So
maybe
we do this process for one model. So like this one is for Llama. We do the same process for other models and then combine, not at the token level.
Okay, thank you. Yeah, it's clear.
Yeah, because I had the same question. So you run like this for each model, you predict for each token the probability over the dictionary of the tokenizer. Then you combine, like build this handcrafted metrics on top of this to aggregate through the entire sequence. And then you get a new table where you would have like those 5 metrics against the, like with their prediction for each of the texts. And then you train a classifier, and what kind of a classifier on top of this? Is it just
on top of it was the XGBoost, light GBM.
Yeah. Thank you.
Thank you very much. Any other questions, comments, suggestions, whatever? We are informal. Don't hesitate. Don't be shy. You can write them in the chat or unmute yourself and ask by voice. Okay, maybe not so more questions for the moment. So may I ask one question? Just so, what was the motivation for this task? Just to predict the different, answers by the LLM. What some possible use or some, I don't know. What did you keep in mind?
Nothing. There is no actually, honestly, there is no intention behind this competition. It's mostly like, just to have fun, actually, to keep you engaged, right? Again, the competition was organized around the conference H2o had in San Francisco on November 7th. So that was one of the reasons why we organized it, to just, as one of the way to keep the community informed about the conference, and just again for sake of doing some interesting stuff and fun for Kaggle community. So, but I don't immediately see any practicality from that particular setup of the competition. Let's say if we aim for practical usage, would be nice to organize something like definitely would be better to split on topics, right? Just to make sure the model actually generalizes behind the scene topics and scene questions. So, and of course, it's going to take more time and bigger data to do that. And on a side note, a second interesting idea for the competition, which kind of have a practical usage. Let's say you have a model, 70 billion model in production. It's actually costly, right? You have to, inference of this model is costly. But what if you actually needed on a 7 billion model only? So can you build a lightweight classifier, which, given the query, the question from the user, can identify the complexity of the question and, dispatch it to the different size models? for sake of, you know, easing the burden on a hardware. That could be one idea we had. I'm not sure it's possible, but that's something, you know, just we might organize in the future. Who knows? That will definitely require. I mean, yeah, sure, it's possible. Okay, that's good. That's good to know. All right. Yeah, that's something we've seen, because I mean, a lot of questions actually, they really seems to be very straightforward, and you don't need a big model to do that. Even just classifying the questions. The other venue, which actually OpenAI does, I think they tracking the. I think somebody actually did that. So they started generating question on a simpler model, and then put this query and the response to some certain point into the bigger model at once to the context, and ask the bigger model to continue generation. That actually might speed up the things, and you can actually balance that in various interesting ways. But yeah, I'm sorry guys, but there is no any practical intentions behind this competition, except just to make something fun.
But we got to learn the world of LLMs, so that is
exactly. It's a learning exercise first and foremost. It's a learning exercise.
For our side, definitely we had a lot of fun, especially when we switched from the DevCon, you know.
That's great. It's great. Thank you very much. I have another question. So now I'm involved in biology, and some language models now are appearing in biology as, for example, this protein language models, which are motivated by the AlphaFold and these developments. So from your perspective, are you looking at this direction? Maybe H2o plan to have something like a studio for biological applications, or I mean, or it's not in the
Well, we're not heavily involved in this particular area of research. So, but I actually don't see why we can't implement something along this line in LLM Studio. I mean, it's relatively straightforward. Pretty much the same text, right? But you just have a different tokenizers and a different, you know, but it's still somewhat textual representation of the biological data. So I don't see actually any reason why it cannot be added to the studio.
That will be very interesting. Last summer, there was a competition on Kaggle to predict the protein properties. And everybody used these protein language models, one from Facebook and another from T5 from some German laboratory. And everybody used embeddings. We also tried to fine-tune these models, but for us, fine-tuning doesn't work. And in the public notebooks, as far as no one managed to fine-tune these models to the particular task. That was surprising, because we know that for the NLP, fine-tuning works great.
Yeah, I mean, I would, it is. I mean, the simple answer, which is, you know, like you can think of as a deep learner excuse, like you just need more data, which is actually somewhat true for biological data, because it is extremely noisy. So that's, I mean, that's the whole effect of big data in general, right? It's kind of help you to remove the statistical tests or whatever you have actually in pattern search. Just because you have so much data, it's already, the patterns, strong patterns already reveal themselves. So maybe the biological data not at that point, because it's more expensive to gather the bigger data sets. At least that would be my experience with biology. Most of the data sets I worked with had like thousands of the, you know, samples versus, you know, like 500,000 columns actually, you know, in some cases, you know, if you think about them in a columnar format. So that's definitely really limiting the usability of complex models. And again, I mean, yeah, I would say the noise is definitely a problem, but it's going to be, again, it's somewhat like sounds like an excuse. Yeah.
Okay, thank you very much. Again, colleagues, don't hesitate. Some questions, comments, or suggestions. So we have a comment from Aleksey in the chat. This idea with the question complexity can reduce the domain classification. From your initial tests, 10 times smaller model can predict how complex OOD this question for a bigger model. I have to draw. Okay.
I have to draw. So thank you very much. Right.
Yeah,
Okay.
just an example. So I don't know, maybe it's just a cool thing, I guess, that basically when you make a something like bigger model just gives you tails of the distribution, but a smaller model can work pretty much with most of the distribution. So it's pretty easy to when you're trying to make trying to predict in out of the main samples, it's a problem because you don't have them in a smaller model. But telling getting this main distribution generally when you don't need tails of it, it's just pretty easy. So for 90% of examples, smaller model can 95, it depends on the data set, of course, but it's really simple. And yeah, you basically you can reduce it to something like domain descriptors, like trim boost and then cut boost on top of this, and you already get a pretty good scoring.
Okay, thank you very much. Thank you very much, everybody. So colleagues, Rob or Samvel or Rashmi, do you have some maybe concluding remarks or whatever comments?
Yeah, I think I'd say similar to what I was saying before, just it was great to see all the participation. I do think that we'll hopefully be doing something similar in the future. And like you all mentioned, even if the direct result of the solutions we can apply to a specific product or application, I think what we've learned in the process is invaluable. And this whole field of LLMs is just moving so fast. I know the specific model that someone mentioned earlier, I hadn't even heard of, and it seems like every week a new one comes out. But really, the complex part at this point is really evaluating how the different models differ from each other in responses, and how we can objectively compare them and say which models are better or worse than others. And part of that is really understanding how they differ. So in that sense, this competition was a huge success because we have some novel ways of now looking at how models responses are different. But yeah, I think this was a great experience. I think thanks again for hosting this chat. I think it was great to have wrap up and to hear from everyone in person.
Thank you very much. Thank you very much for organizing, for participating in the competition and in this meeting today. Well,
Thank you.
Okay, so maybe we are going to the end. So good evening to everybody, and the video record of this will be on YouTube on our channel, I hope tomorrow. Yeah, so thank you very much again. And if you organize something, Rob, please let us know. We'll try to advertise it and attract more people.
We will let you know for sure. Thanks for doing this.
Thank you very much.
See you. Bye.
Thanks. Bye.
Goodbye.